So this is the lecture series on vacuum systems, a very important part of the mass spectrometer, and without them our gas phase ions will not transition down the experiment from the beginning to end because they will be quenched by the air. And so it's important for us to know within our instrument what the vacuum is at the various different points, from source to quadrupole to the detector. And so we need to be able to read and understand what the different pressure readings are that we have in our instrument. And so most instruments measure the pressure in bar or millibar. That's this section here. And that gives you some idea of the conversion rates between the different units of pressure that we can record. So I'm going to take you through the lab looking at where we read those different gauges. So follow me. Now, in a very old experiment here, the Kratos magnetic sector electron impact ionization mass spectrometer, the gauges are down here and they are manual mechanical gauges. On this side we have the gauge that reads the backing pressure. So this particular gauge shows us the pressure behind the backing constant. You can see the backing constant just there. And so this gauge will only read to about 10 to the minus 3 millibar because it backs up our line there for our roughing pumps. And so if I put some air into the system, you will see that the gauge increases. And then when I close the air off from the system, you see that the gauge goes down. And so before our high pressure gauges turn it on, we need to have a good roughing pressure, at least 10 to the minus 2 millibar. And now this gauge right next to it is the gauge for the ion gauge. Now this one is closer to 10 to the minus 6. This particular experiment doesn't have any air or gas or nitrogen or helium or anything running through it at all. So you can see that it's reading just over 10 to the minus 6 millibar. If I open up the gate valve slightly and into that experiment, you will see the gauge increase. Okay, so we need to be able to locate where the gauges are on our instrument and then be able to read them to know that it's okay to go ahead with the experiment. So this particular instrument has a source region followed by the magnetic sector, followed by the detector here. The detector region has a ion gauge in it as well as the source. So this particular button here is reading the source pressure. If I now click it over, it now reads the analyzer pressure, which is where the detector is. So the same gauge is able to read two different ionization gauges. So most of the instruments nowadays have their gauges connected to the software, and you can read the actual pressure of the software in the gauge in the software. So for instance, this is the GCMS, and you can see here we have the high vac pressure. So this is the pressure in the mass spectrometer. The GC mass spectrometer just has one gauge throughout the whole thing because it's pretty small. This is the size here of your mass spectrometer in your GC. Here is the ion region, the quadrupole, followed by the detector. And the whole thing has, I hope you can read, 10 to the minus 5. 3 times 10 to the minus 5 millibar. Now that's a high pressure. And the reason for that is the GC has helium gas from over here running through the instrument at all times. That means that the pressure is never really, really low. It's the helium that carries our molecules of interest from the column all the way to the mass spectrometer. Okay, so another instrument that has all the pressure readings in the software is the electrospray, and this is a quadrupole followed by a time of flight instrument. And on the tune page of the software, there's an icon here that shows pressures, and when I click on it, up comes 3 different pressure readings for 3 different sections of the instrument. So this particular instrument has a Pirani, which is the backing gauge, and that is here at about 10 to the minus 1. Now that pressure gauge is just behind the source here. That's a really high pressure, and so just behind the source is the Pirani. Can we see it? You can see it right there. Okay, and the reason that that pressure is so high is because with an electrospray instrument, there is a hole into the instrument at all times. You can see it directly in front of this picture. That hole allows your electrospray aerosol to enter the instrument. So in effect, there's a tiny hole. Hence the reason why that poor pump is at 7 times 10 to the minus 1. It's working hard always to be pumping the air away. The next one is the analyzer penning, and that is at the end of the quadrupole. Okay, so this particular instrument has 3 different sections. At the end of the quadrupole, we're reading 4 times 10 to the minus 6, and then there'll be a very small aperture into the top penning. This is our very high pressure region, 1 times 10 to the minus 7, and where we're actually going to analyze our molecules and detect them. That is differential pumping from beginning to end, with the vacuum getting better as we go from one section to the other, and the really good vacuum being, of course, in the detector region. So most of the instruments nowadays have the pressure readings on in the software, and so it's important to not only know where to find them, but to understand what it is that you are reading when you do find them. So again, this is the Synap. Now the Synap has another section. Again, we have a backing pump, which will be a Pirani. We have a trap, which will be a penning, an IMS, and then a top. You can see that the trap and the IMS vacuums aren't very good, but the pressure that needs to be really, really good, 10 to the minus 7, is at the end of the instrument at the top. Okay, so not only is it important to know what a good vacuum is, it's important to know what gauge is reading what and where you can find that information. Thank you.